DualNetView. DualView is for visualizing dynamics of networks by Vĩnh Phạm, Ngân Nguyễn, and Tomida from Interactive Data Visualization Lab, Computer Science Department, Texas Tech University. Motivation of this work is that the force-directed LiDAR is a popular visual method for revealing network structures such as clusters and important vertices. However, it is not capable of representing temporal patterns such as how clusters or community evolves. Therefore, the dynamic visualization trades the overall structures for temporal relationships. In this paper, we present a DualNetView framework for capturing both overall structures and temporal patterns within the networks. The link supplemental views utilize the strengths of both visualization techniques to provide useful insight into the given networks. DualNetView visualization and interactions. The first component of this DualNetView is the force-directed node link networks on the left. This one helps to provide overall structures of the network. Nodes are the circles designating participating computers in this case. Node size indicates numbers of interaction involving within it. The colors of the nodes indicate its type, such as inside, unknown, or outside for this case. On the other hand, links represent communication among nodes. Link colors represent its communication type, like permitted, MBL, or none in this case. The loopback link means the source and the target are the same. The force-directed layouts help to bring nodes with more communication together, which help to form clusters and also help to bring the most important nodes into the center. The second part of this DualNetView is the force-directed dynamic networks. It helps to provide temporal patterns of the network over time. The horizontal lines represent participating nodes. Colors indicate their types, just like previously described. Thickness represents the group of nodes. Let's say for this, it contains a group of nodes with similar communication patterns. The arrow-headed X represent communications among nodes. Color encodes communication types, as described previously as well. Thickness designates the number of communication at a time. Force-directed layout. Because of the time constraint, this force-directed layout is used to bring the nodes with related nodes together in the vertical orientations. This one is also help to detect communities as well. Interactions. Several of the interactions are provided to dig down into details of any pressure events of concern. Let's say users can mouse over a node to view its information and its related records at the tables at the button. Users can also click on the link to view all the communication within that link display on this table as well. Users can also mouse over any nodes on the horizontal lines here to view its related interaction over time. Use cases. DualNetView's use cases. A natural application of network analysis is for analyzing computer network. Therefore, we apply a solution to investigate one-day network threat log from a subnetwork of an organization. This one-day snapshot contains 3,448 network communications among 157 unique devices inside a subnetwork. One IP is from outside, and others are unknown sources. It is observable from these node-link networks that there are 4 clusters among the devices: cluster 1, cluster 2, cluster 3, and cluster 4, and 2 suspicious addresses, as from outsider and unknown sources. 2 clusters, cluster 1 and cluster 2, was being attacked by an outsider and also unknown sources. On the other hand, cluster 3 and cluster 4 was only attacked by the unknown sources only, and they also have loopback. It is feasible that from 3 p.m., the outsider network attacked the network massively. This attack would assume to be scanning process that the suspicious attackers were using to look for vulnerable devices inside the network. After this massive scanning, From about 6 p.m. onward, unknown sources periodically communicated with a group of computers inside the network. All in all, this use case demonstrates the utility of dual view approach. One has to give an overview and indicate suspicious events and cluster while the others examining the temporal patterns. This timeline view is useful to discover temporal pattern. However, it's still kind of hard to track and follow the paths. For examples, it is not trivial to visually discern the degree of separation between the outsider and the unknown source, and they are very clear and evidently separated in the node-link force-directed layout. We also apply DualNetView approach to analyzing a malware. Specifically, in this case, we use network analysis for the server.exe malware. The blue X are process creations. The loop X are SAP calls. Network over here depict that server.exe in this red circle is a very busy node and it is brought to the center. This helps to narrow down about the item for us to inspect later on. In dynamic networks, it depicts server.exe behavior over time. For instance, a system is called to cmd.exe and cmd.exe in turn called to several of other processes like ping, taskqueue, and callhost.exe as well. All in all, the dual approach view helps to analyze this malware very well. Node-link network helps us to investigate related nodes, and on the other hand, the dynamic network helps us to discover attack patterns of the malware. In this third use case, we outline DualNetView to analyze social network. This social network includes all the activities from 20 casual employees. Those employees are filtered by suspicious people. The arrow-headed X represent types of communication among them. The node-link network depicts the overall communication structure within this group created over time. On the other hand, the dynamic network represents the communication pattern over time. It's interesting that from this box A, Christine and Rosalia made several of the phone call communication before Rosalia made the suspicious purchase with Janice at this time, and then after that they made a series of other phone calls to communicate about this suspicious event. This use case is also used to depict the helpfulness of combination of the two views, the node-link diagram with aggregation of communication over time and also the temporal pattern to detect the suspicious event. Implementation, source code, and a web prototype of this approach is given in this link address. Conclusion. DualNetView approach provides a node-link network to give the overall structure of the network aggregated over time. The dynamic network focuses on the temporal details. Interactions help to drill down into events of concern. Also, this will provide several use cases of using DualNetView in analyzing computer networks, malware, and also analyzing social networks. In the future, we'll investigate the scalability of the system. We'll recommend suitable operations such as adaptive aggregation, and furthermore, we'll also have navigating and exploring large dynamic networks at different levels of granularity. Thank you. And if you have any questions, you can address now, or please contact us at vững@ttu.edu or Ngân or to me that with email given over here. And these are the references to the use cases that we listed above.